Going to do the experiment of Zener diode characteristics. So first of all, let me give the introduction to the Zener diode. Zener diode is heavily doped diode compared to the ordinary PN junction diode. If we improve the doping levels in the PN junction diode, we are going to construct the Zener diode. So Zener diode can be connected in two ways. One is forward bias and the other one is reverse bias. So under forward bias construction, it works as similar to the PN junction diode only. When coming to the reverse bias, it has a special feature. It won't actually in Zener diode under reverse bias condition there should not be any flow of charge carriers. But as we are increasing the doping levels, the depletion width of the Zener diode will increases and thereby it reaches a particular voltage where the charge carriers are suddenly increased along this junction. So therefore, the current will increase at a particular voltage. That particular voltage at which current suddenly increases will be called as a breakdown voltage. So we are in this experiment, let us see the components required and the characteristics under forward bias and reverse bias, and we will observe at which voltage we are getting this breakdown. So let us proceed with the connections now. Now let us see the circuit diagram connections. Circuit can be connected in two ways. One is forward bias, the other one is reverse bias. Under forward biased connection, positive terminal of the diode is connected to the positive terminal of the external voltage and negative terminal of the diode is connected to the negative terminal of the external voltage. And to measure the voltage, we are using this voltmeter which is connected across this diode, which is ranging from 0 to 20 volts, and to measure the current through this diode we are using this ammeter which is ranging from 0 to 200 milliamps and connected in series with this diode. Here I am using this resistor of 1 kilo ohm to protect this diode from the sudden fluctuations from the external voltage. So this is the construction for forward bias, and similarly we can do the construction for reverse bias by simply interchanging the terminals of the diode. So if I am connecting the negative terminal of the diode to the positive terminal of the external voltage and positive terminal of the diode to the negative terminal of the external voltage, we can consider or we can call this construction as reverse bias construction. So by using these circuit diagram connections, let us do the experiment. Now let us do the circuit diagram of Zener diode characteristics. This is the physical device of Zener diode which has two terminals. To identify the anode and cathode, we have black color strip to the right side. So this terminal is called as cathode, the opposite terminal is called as anode. And this is the 1 kilo ohm resistor, and this is the breadboard which can be used to construct the circuit diagram. Above two lines are used for grounding purpose and below two lines are also used for the grounding purpose. In between we are going to do the circuit connections. To measure the voltage across the diode, we are using 20 volts digital voltmeter, and to measure the current through the device we are going to use 0 to 200 milliamps digital ammeter. And to provide the external voltage, we use regulated power supply which is ranging from 0 to 30 volts. It has two terminals, two channels, we are using only one channel. Now let us do the circuit diagram. So I am taking the Zener diode. In this breadboard, I am using this breadboard to connect the Zener diode like this, and it has to be connected on the same line. And I am taking this 1 kilo ohm resistor, and to the same node of this Zener diode we have to connect here like that. The voltmeter positive terminal is connected to anode of the diode, and negative terminal of the voltmeter is connected to the cathode of the diode. Then ammeter positive terminal is connected to the cathode of the diode, and a negative terminal of the ammeter is connected to the ground. And external voltage, this is positive terminal and this is the negative terminal. Positive terminal is connected to the positive terminal of the anode through this resistor. And negative terminal of the supply is connected to the ground. Make sure the connection should be properly done. This is the circuit diagram. So make sure the connections are to be done properly before switching on the voltmeters and power supply. So I have verified and I am turning on the voltmeter, ammeter and external power supply. So by varying this power supply, I have to measure this voltmeter and I have to measure this voltage and I have to measure this current. So change this voltage. For 0.1 volts external voltage, there is 0.1 volt and there is no current, and still you increase this to 0.2, 0.3, there is no current, that means current has not started. 0.4, 0.35, there is no current. At 0.7, at 0.8, the current has started. See, at 0.1 external voltage, we have 0.68 diode voltage across the diode, and we have the current 0.1 milliamps. That means this particular voltage 0.68 at which we are giving external voltage will be called as the cut-in voltage of the diode. So we have to note down all these values by varying this external voltage. So I am noting down the values and I am going to draw this graph for that. So to note down these values, we are using supply voltage. For 0 supply voltage, I got 0 voltage and I got 0 current, and till 0.7, 0.1 to 0.7, this particular voltage will be called as cut-in voltage of this external voltage. So when we are applying 0.7 voltage as external voltage, so this is the internal voltage of the diode and this is the current through the diode. So before till this point we are going to get the 0 current. So that means there is no movement of the charge carriers. Soon after reaching this voltage, we are going to get this current. So similarly, likewise we are going to vary this external voltage and we are going to measure this current. For 2 volts of external voltage, we got 0.76 and we got 1.2 milliamps of current. Okay. Likewise, we can change this current by changing this external voltage. So for 5 volts external voltage, we got 0.80 as the diode voltage and 4.4 as the current. So by using this forward voltage and forward current, we are going to draw the characteristics This is forward voltage, this is forward current. So up to 0.6 we don't get any current. So after this we got 0.1, 0.2, 0.3 and so on up to 1, 1.5, so 2 like that. So we are going to get the graph like this. So this voltage is called cut-in voltage. This is the forward characteristics of Zener diode. Now let us do the reverse diode. By simply interchanging. Before that, let us switch off this one. So simply I am going to change the terminals of this diode. So initially I have connected anode to positive terminal. Now I am connecting cathode to positive terminal. Okay. So I can use here 0 to 200 microamps, milliamps, or I can use 0 to 200 microamps. So whenever I am changing this voltage, for 0.1 I got 0.09 and I don't get any current. So 1.5 I got 1.36 as the voltage and 0.1 milliamps. If I am using 2.5, I am getting 2.29 as the diode voltage and 0.2. See, observe, if here we are getting very little current. For 5 volts, I got 4.6 as diode voltage and 0.4. So like this, if I am observing, voltage is not varied but current is increasing. So that means we have to keenly observe at which breakdown occurs. Yes. So at 8 volts external voltage, 1.2 milliamps currents are there, and if you observe, this voltage is not varied even if I change this to higher voltages. So see, even if I am changing to 9.2, the voltage is maintained at 6.7. So that means the voltage is maintained constant. So this is the major important feature of the Zener diode, which can be used as voltage regulator. So if I am noting down all these values, then I can get the reverse characteristics of the diode. So like that, if I am going for 9.2, I got 6.78 and 2.6. So if I am changing this to 9.5 or 10, 10 volts, the diode voltage is 6.78 only and we are getting 3.4. So, if I am increasing this to 11, it is going to be 6.79 and the current is 4.4. So, if you observe here, the voltage is constant, reverse voltage is constant and the current is very minimum. So, the feature where we are getting the constant voltage, so this makes us to use the Zener diode as voltage regulator. Okay. So, you use this voltage and currents to draw the graph. This is reverse voltage and this is a reverse current. So, here there is a small variation in the voltage, though we are increasing the external supply more. So, this feature is making us to use this Zener diode as voltage regulator. So, this is the experiment of Zener diode. So, we use these values in order to draw the graph. So, in the graphical sheet we have to draw the forward bias characteristics and reverse bias characteristics. These are the readings of Zener diode characteristics under reverse bias. So, even if you are changing large voltages of external supply, we are getting the constant after 6.78 we are getting the constant voltage even if you change the voltage. So, this is the current. So, this is the important feature where we are using the Zener diode as voltage regulator. That means voltage is regulated here, it is controlled even after changing the external voltage. So, by using this we have drawn this graph. So, this is breakdown voltage at which we are getting the constant voltage and current is increased. So, this is the total experiment of Zener diode characteristics under forward bias and under reverse biased conditions. So, by using these observations, we are going to draw the graph and we are going to mention the breakdown voltage and we will use the Zener diode as voltage regulator. So, thank you all.